Internet and World Wide Web. Foundations of modern communication. The Internet and the World Wide Web are foundational elements of modern communication and information sharing. While often used interchangeably, they represent different concepts that work together to create our online experience. The Internet is a global network of interconnected computers communicating via standardized protocols, serving as the backbone for services like email, file sharing, and web browsing. The World Wide Web, on the other hand, is an application running on this infrastructure, a system of interlinked hypertext documents accessed via the Internet. This presentation explores the fundamental concepts, components, and functionalities of both systems, along with the crucial roles of web browsers, servers, and the protocols that enable their communication. Understanding the Internet originated in late 1960s as ARPANET, developed by the US Department of Defense. It evolved through various stages before becoming widely accessible to the public in the 1990s. A key feature of the Internet is its decentralization. It isn't controlled by any single entity but exists as a distributed network of servers and devices. Communication is governed by protocols such as TCP/IP, ensuring data is transmitted accurately and efficiently. The Internet's infrastructure consists of both physical components and logical components, enabling the transfer of data packets across various networks worldwide. 1960s ARPANET, developed by US Department of Defense. 1980s TCP/IP protocols, standardized. 1990s public Internet becomes widely accessible. 2000 plus mobile Internet and IoT expansion. The World Wide Web. The World Wide Web is a system of interlinked hypertextuments accessed via the Internet. It allows users to view and interact with web pages containing text, images, videos, and other multimedia content. While the Internet is the infrastructure connecting computers, the WWW is an application running on this infrastructure utilizing HTTP to transmit data. When a user enters a URL in a web browser, the browser sends a request to a web server, which responds with the requested web page. The WWW operates on standards set by organizations like the World Wide Web Consortium, ensuring interoperability and accessibility across different platforms and devices. Web applications, interactive applications with dynamic content, web pages, HTML documents with unique URLs, web server store, and serve content upon request. Internet infrastructure, physical and logical network components, types of websites. The web hosts various types of websites, each serving different purposes and utilizing different technologies. Static websites display fixed content that doesn't change unless manually updated, typically built using HTML and CSS. They're simple and fast but lack interactivity. Dynamic websites generate content in real time based on user interactions or other variables, often using server-side scripting languages like PHP or ASP.NET. These sites provide personalized experiences but are more complex to develop. Other common website types include e-commerce platforms facilitating online transactions, blogs sharing personal insights or information, and social media platforms enabling content creation and social networking. Static websites, fixed content that rarely changes, built with HTML and CSS, simple and fast loading but limited in functionality. Dynamic websites, content generated in real time based on user interactions, uses server-side scripting for personalized experiences. E-commerce platforms facilitate online buying and selling with features like shopping carts and payment gateways. platforms. Social media and blogs enable content creation, sharing, and social networking with interactive features. Web browsers and servers web browse act as clients in the client server model, initiating requests for web pages. They render HTML documents and display them to users, allowing for interaction with the content. Popular examples include Google Chrome, Mozilla Firefox, and Safari. Web servers process incoming requests from clients and send back the requested resources. They can host multiple websites and manage traffic through various protocols. The interaction begins when a user enters a URL, prompting the browser to perform a DNS lookup to find the server's IP address. After establishing a TCP connection, the browser sends an HTTP request and waits for the server's response, which contains the requested web page or an error message if the content is unavailable. Browser request enters URL. Browser initiates request DNS lookup URL translated to address server processing server receives and processes request response delivery server sends back requested content HTTP communication. HTTP is the foundation of data communication on the web. An HTTP request message consists of a request line specifying the method and resource URL, headers, additional information, and an optional body containing data for post requests. Common HTTP methods include get, post, put, and delete. When the server receives a request, it responds with an HTTP response message containing a status line, headers, and the requested resource. Status codes indicate the outcome of the request. 200 for success, 404 when a resource is unavailable, and 500 when the server encounters an unexpected condition. And HTML HTTP 1.0 host user agent 5.0 accept text HTML response example HTTP 1.200 content type text HTML's content length 1234 hello world. Web security considerations HTTPS, a secure version of HTTP, uses SLTLS to encrypt data transmitted between client and server. This encryption is essential for protecting sensitive information like passwords and credit card numbers from interception. Common security threats include phishing attempts to obtain sensitive information by disguising as trustworthy entities, man-in-the-middle attacks intercepting communications, and DDoS attacks overwhelming servers with traffic to make them unavailable. Best practices for web security include using HTTPS for all applications, implementing strong authentication mechanisms, and regularly updating software with security patches to address vulnerabilities. HTTPS encryption secures data transmission using SSTLS protocols, protecting sensitive information from interception. Common threats phishing, man-in-the-middle attacks, and DDoS attacks pose significant risks to web security. Security best practices use HTTPS, implement strong authentication, and keep software updated with security patches. Future trends in web technology. The web continues to evolve with emerging technologies shaping its future. Progressive web apps provide native app-like experiences, including offline capabilities and push notifications, bridging the gap between web and mobile applications. WebAssembly enables high-performance applications to run in browsers by supporting languages C and C++, expanding web capabilities beyond traditional JavaScript. Artificial intelligence and machine learning are increasingly integrated into web applications, powering personalized experiences, chatbots, and sophisticated data analysis. Web accessibility remains a critical focus, with ongoing efforts to make the web more inclusive for users with disabilities through compliance with standards like WCAG. Progressive web apps, native app like experiences with offline capabilities, WebAssembly high performance applications in browsers, AI integration, personalized experiences, and intelligent automation. Thank you.